Alrighty, so we have journal 39, and in our bell work today, this is actually a problem you're going to see on the Unit 5 test. So it's talking about Lily, and she is trying to find f minus g. And so here's f, and here is g. So we're going to take a look at how she worked out this problem and see if she made any mistakes. So looking at the first line here, I can see that she wrote in f and she wrote in g, and I like that she wrote in parentheses because we're subtracting. So whenever you're subtracting, it's really important that whatever you're subtracting with, which in this case it's the g, that needs to have parentheses, okay? So why does that need to have parentheses? Well, because you need to distribute this negative to both terms. So let's see in the next line if Lily did that. So looking at this here, it looks like this is just brought down from the first parenthesis, so it's brought down, and she multiplied the negative with this x, so negative x, but it looks like she forgot to multiply this negative with this negative 3, so this should be positive, but in this case it's not, so this should have been positive. So it doesn't look like she's completely correct, so I'm going to say no. She forgot to distribute her negative. And let's see if she made any other mistakes here. So the next line, she continues to combine her like terms, and it looks like she takes 5x with her negative x and gets 4x, which is correct. And she would have taken her positive one and minus it, subtracted with the 3, and got negative 2. So it looks like the rest she did fine. It was just that negative wasn't distributed. So, but let's answer that third line here. So it says, describe what she did well. So let's put some kind words for Lily. So it looks like everything is done correctly except for the distributing negative part. So I'm going to say the one thing that I really liked that Lily did was that she put parentheses around that g function when she was subtracting. So that's always encouraged so that you can remember to distribute that negative. So she used parentheses is what I'm going to say that she did well in. All right, so we're going to move on to today's lesson, which is... Alrighty, so in today's lesson, we're going to be learning how to simplify roots. And we've learned a little bit about simplifying square roots and cube roots, but now you can see here, we're taking it on to another level. We're going to be talking about the 5th root, 6th root, and even higher than that. After today's lesson, you should be able to take the root of any type. So I'm going to teach you how you can do this by hand, but also how you can do it in the calculator. So by hand, let's start with something we already know, like the square root. So to the side here, let's think about the square root of 9. So the square root of 9 is 3. Hopefully you already know that. But how we can actually figure this out by hand is first decomposing or making a factor tree of the number inside the root. So if I were to make a factor tree of 9, I want to ask myself, what are some numbers or two numbers that multiply to give me 9? And you guys are probably going to say 3 times 3, right? So when I multiply these two numbers, I should get 9. And so another thing you want to think about is, if this is a square root, then the number outside of this root is going to be 2, okay? With cube roots, you can see that the number outside is a 3, 5th root, there's a 5, 6th root, there's a 6 outside. So for a square root, you typically don't have anything outside, but by default, it's always going to be 2. So what does this 2 really mean? Well, it's saying there are two numbers that are identical when multiplied, gives you the number under the root. So in this case, the two identical numbers are 3. There are two 3's here. So that's why the square root of 9 is 3. So we're going to use that same technique, that factor tree, to help us figure out what is the cube root of negative 64. So, all right, so looking at this here, I have a 64 here. And I am going to make a factor tree for the 64, so let's think about it here. 16 times 4 gives me 64. 16 can be decomposed as 4 times 4. And when I look at this, there looks like there are 3 4s here, right? So whenever you're taking a cube root of something, it's saying there are 3 numbers that are the same that when multiplied with each other should give you 64. So in this case, 4 times 4 gives you 16, times another 4 gives you 64. So it looks like here, if I take the cube root of 64, I should get 4. But because there's a negative sign here, this needs to be a negative. Because, well, if this was a negative 4 multiplied by another negative 4, that would give you positive 16, times another negative 4 gives you negative 64. So our answer for the cube root of 64, negative 64, is negative 4. Let's try B next. So here I have 243, and I'm taking the 5th root. So that's saying there is a number multiplied each other 5 times gives you 243. So let's decompose 243 using a factor tree. So I believe 81 times 3 gives you 243. 81 can be decomposed as 9 times 9. 9 can be decomposed as 3 times 3. And 3 times 3. So when I look at this here, it looks like I have 1, 2, 3, 4, 5 3s. So in this case, I have the 5th root of 243 is 3, right? Because there's 5 copies of 3, so in this case, the 5th root would be 3. So that is my answer. And last but not least, I have part C, which is asking me what is the 6th root of 1? Well, 1 times 1 is 1, but if I multiply it 6 times by just 1, let's see, 1, 2, 3, 4, 5, 6, this is still going to be 1, right? So in this case, the 6th root of 1 is just 1. And that's it. Okay, so in your calculators, here's how you're going to do it. When you're in the calculator, you're going to press Math, which is the green button. And then you are going to press, so the next button here is option 5 on the calculator. It looks something like X, the square root, with a square root symbol. But what it's saying is you can plug in any root value and any value inside the root in the function. So that's going to get you to this symbol here. So try that out, and that's going to help you find the roots of any type of situation using the calculator, so you don't have to make a factor tree. So it's just a great way to check too. Okay. So now let's talk about converting roots to exponents. So here you can see that I have now given you guys not numbers, but variables with exponents on them. So what we're going to do is complete this formula here. This is actually not the formula. It has something missing, but we're going to figure out what is missing exactly. So what we're going to do is start by investigating these two by using a simple factor tree and finding the in this case looks like a square root and a cube root, and see if we can find a pattern. So let's start out with part A. So for part A, notice that this here is a to the 6th power, and because this is a square root, that means there's a 2 out here. My root is 2. So I'm going to write a 2 outside here. Let me move this to the other side. There we go. I'm going to put a 2 here. So when I look at this here, this is saying that there are 2 numbers that are the same when multiplied. Gives me a to the 6th power. Now, if you can't figure out what that is, what you can do is write out all of the A's. So I'm going to write out all the A's. Why does this keep moving? A times A times A 6 times. So let's write out all those A's. Now, all these A's here, the power for each one of them is 1, right? This is A to the 1 power. 1, 1, 1, 1, 1. And so when I look at this here, when you multiply a variable, you add the exponents, right? So if I add all these up, I get 6. And so if I'm taking the square root of this, I have to make 2 groups with the same amount of things in it. So if I were to make 2 groups, how many A's would I have in each group? Well, if I put this in a group, there are 3 A's. And if I put this one in a group, there are 3 A's. That's an even amount in each group. So let's count how many A's we have. So we have 3 A's. So this is, if I multiply all 3 of these together, I have A to the 3rd power. This one's also A to the 3rd power. And if I multiply these two, well, I get A to the 6th power. So in this case, the square root of A6 is A to the 3rd power. And that is the square root. So I'm done. We're going to do the same type of technique with the part B, and it is to the 3rd root here. And this is A to the 12th power. So what I'm going to do, just like I did before, is write out all my A's. So I have A times A 12 times. So we're going to write all of this out. I know it's a little tedious, but I promise you, we will soon see, if you haven't already, what is happening here. So that way we can find a formula for this to make it easier on ourselves. So looking at this here, we have 12 A's. Hopefully I've written all 12 of them. Looks like I've written all of them. So now what we're going to do is form 3 groups, and it has to be an even amount of A's in all of them. In other words, all of them should have the same amount of A's in each group. So it looks like because there are 12, I might want to just put 4 in each group, right? Let's see here. Yeah. So now we can see that each group has 4 A's. So that means if I multiply that, all that is A to the 4th power in each group. So if I multiply all these, I would add the exponent and get back to 12. So it looks like the cube root of A to the 12th powers is A to the 4th power. Okay, now what did we actually do here when we took the root of an exponent, a variable with an exponent? So you might have noticed we were taking the exponent and actually dividing it by the root. In other words, anytime I have an exponent, let's call m on the inside, and a root on the outside, let's call n, I'm doing a to the m divided by n, the root. So that's my formula there. This is super important. I would write that down in your notes. So that's going to help us out when we're solving these problems, so we don't have to always write those A's out or X's, Y's, whatever letters that they need. So let's do part C, but this time around, let's use our formula here. So for C, we have X to the 16th power on the inside and Y to the 8th power. So what we do is we take that exponent on the X, so the X here is to the 16th power, so 16 divided by 8, which is my root on the outside, is going to give me 2. And then Y, this 8 divided by this 8 gives me 1. Or you can just write it as X squared Y instead of Y1. But I'm just going to write that there just so you guys know that I did divide. And that's it. So let's put all this information together and do a few more examples. All right, last slide for today. So looking at this here, we now have a combination of numbers and variables underneath our roots. We have got some parentheses here, negative signs. So we have quite a variety here. So let's start with A. Anytime you are dealing with a number inside a root and variables, you want to do them separately. So you want to do the numbers separately from the variables. So what I'm going to do first is take 32, and I'm going to take the fifth root of it. So I'm going to ask myself, what is the fifth root of 32? So you can put this in your calculator and get a value, or you can build a factor tree. So 32, 1 multiplies to give me 32, 8 and 4. 4 can be decomposed as 2 and 2. 8 can be decomposed as 4 and 2. 4 can be decomposed as 2 and 2. So the fifth root is, let's see, let me count on how many 2's we have here. So 1, 2, 3, 4, 5. I have 5 2's, so the fifth root of 32 is 2. So that tells me I have already taken the root of my constant, and I got 2. So now what I'm going to do is actually take the root of the variable. So a to the 15th power, so 15 power divided by 5 gives me a to the third power. B, which has to the 10th power divided by 5, is going to give me 2. So it's really important that when we have that constant there, this actually, you take the root of that, okay? So you can do that in the calculator or by hand. But when you're doing the variables, all you're doing is taking that exponent and dividing it by the root. Okay, so it's really important that you do not mix that up with the constant. And a lot of people that I see sometimes will take the constant and divide it by the root. Don't do that here. All right, so this is our final answer. Looking at B here, we have something in parentheses to the 6th power. What is the exponent or the root that goes here? So if this is a square root, by default, there is a 2 outside. And if I were to take the square root of this exponent, that means I would do 6 divided by 2, right? Which gives me 3. So my new exponent is 3. But what do I do with the stuff in the parentheses, right? So I'm going to just drop down the stuff in the parentheses as 2x plus 1. And when I divided this 6 by 2, I got 3, so I'm going to put the exponent right here. Okay, looking at this here, I'm actually going to stop here. This is my final answer, because it just says to simplify, and I could FOIL this out, write it 3 times and then FOIL, but I'm not going to. It's just not necessary. We're just taking the root. So now let's take a look at C together. I'm going to erase a few things. Oops, I think that was the wrong eraser. Let me erase this. So looking at this here, for C, I have a negative on the outside here. Make sure you don't distribute this negative to this root, okay? This is not a -4 or a -4 root. It's just a negative on the outside. So in this case, whenever I take the root, I'm going to have a negative on the outside. So I'm just going to go ahead and write that out so I remember to put a negative in front of everything. But just like before in part A, if this is a number here, you want to take that root separately from the exponent. So ask yourself, what is the 4th root of 81? Well, I can build a factor tree, make this 9 times 9. 9 can be decomposed as 3 times 3. And so now when I'm looking at this, it looks like I have 4 copies of 3's. So the 4th root of 81 is 3. So I have -3, and then I have x plus 4. This is to the 4th power. So if I divide this 4 by this 4, I get 1. Or you don't have to write the 1 there if you don't want to. And that is my answer. You could distribute this -3. You do not have to, though. I'm just going to leave it the way it is. Okay, so for part D, last problem here, we have a cube root and we have a constant inside and then variable. So just like before, we want to take the cube root or the root of the number first, and then the variables. But before we get started, I want you to ask yourself, can we actually take the cube root of this if there's a negative sign inside the root? The answer is yes. We can take the cube root of a negative value. Remember, whenever you have an odd root, like 3, Or another odd root is the 5th root, the 7th root, the 9th root, any odd number. You can take the square, so if I have an odd root, you can take the root of a negative number, and that is okay. But anytime you have an even root, like a square root, you cannot take the square root or an even root of a negative number because that gives you an imaginary number. So those are some notes that might be helpful when looking back. So taking a look at this problem here, we are okay to take the cube root because this is a odd root. So in this case, what is the cube root of negative 27? Well, if I build a factor tree, this is 9 times 3. 9 can be decomposed as 3 times 3. So it looks like I have 3 3's here, so it's a 3. But because it's a negative 27, I need a negative 3. All right, so when I look back at this problem here, this is negative 3x. Let's see. This x here is to the 18th power, so 18 divided by 3 gives you 6. And then y is to the 6th power, so 6 divided by 3 gives you 2. And so that is my final answer. I hope that helped you out. So that's it for today.